Hi, this is Mr. Cappert. In this lesson, I'm going to teach you guys how to draw free body diagrams. This goes along with the Truss Bridge project. A free body diagram is just a diagram or drawing that shows all the forces acting on an object. There's 4 important rules for this. You want to isolate the object that you're studying, so you don't want any of the surroundings in your diagram or drawing. Each force must be labeled. Forces are represented by arrows always. The forces acting on the object are shown. So on the object, not the ones that the object's exerting on other objects. So you want to draw what is happening to that object, not what it's doing to its surroundings. Typically, you represent the object with a box. You'll see in the examples it's not always true. If it's something very difficult to draw, typically you use a box or a point. But if it's something like a ball that you're drawing a free body diagram of, just draw a ball. That's fairly easy. The truss bridge, these bridges are not too difficult to draw, so you'd also want to draw those out. And I have an example coming up. Here's a real basic example with the Statue of Liberty. Notice represented it with a box because it is hard to draw the Statue of Liberty. I didn't draw its base. I didn't draw these cars out here. I didn't draw the trees. I isolated just the Statue of Liberty and said this box is the Statue of Liberty. Notice I put all the forces that are acting on the Statue of Liberty. So FW, that's always going to be force of weight. So anytime you have an object, it obviously has a weight. You're going to call that FW. If you have multiple weights, then you might want to say force of weight liberty, for instance. You put the W in subscript. So Statue of Liberty has a weight of 496,210 pounds. Counteracting that is its base, which is pushing up, holding it up with the exact amount of force, same amount of force. The normal force, that's where the Fn comes from. Anytime you have a surface holding something up, typically you call that the normal force. So F subscript N. Here's an example for your truss bridge. You have these abutments holding up the bridge, and you have, for instance, a package on the bridge right in the center of it. So once again, even though it's easy to draw these abutments, A and B, you do not want to draw them in a free body diagram. Isolate just the bridge, what you're studying. So if I say draw a free body diagram of truss bridge, just isolate that truss bridge. I actually labeled these abutments myself. They originally didn't have an A and a B, so I said A and B. That way I could have the forces labeled. So I have the force from the abutment A holding it up. I have the force of the box pushing down on the bridge. One that people tend to forget about is that this truss bridge actually has weight itself. So that's what FW, force of weight of the bridge, is in this example. Once again, if you had other weights in here, you'd want to call this force of weight bridge. But since there's only one, it makes sense to just say FW. That's going to be, weight's always going to be pointing down towards Earth, whereas FA and force of abutment B are pressing up on the bridge. You could actually draw this weight down below here too. As long as it's in the center, it's acting on the center of the bridge. Here's a little more complex example because you have a force at an angle. The person pulling the sled, they're pulling on a rope that's being pulled at an angle to the up and to the right. You have the weight of the sled. They kind of simplified this. If you really wanted to get into detail, you have the force of weight of the girl, force of weight of the boy, force of weight of the sled. Once again, unlike them, I would put F subscript W for my weight. Normal force, that's what you call a surface that's holding something up. F of F, that's the friction of the snow that's trying to stop the movement of the sled. So instead of drawing it like this, you want to isolate what you're studying. In a sled, they just represented it with a box and put the forces on here. So you have your friction trying to slow down the sled. You have applied force, someone pulling on the string. You have the ground, the normal force holding it up, and you have the weight of the two kids in the sled. Here's another example. They put a little bit more detail than I need from you guys, but you have a box here, let's say a package that's being pulled on by another package that's going around a pulley. You want to isolate what you're drawing a free body diagram of. So if I say draw a free body diagram of this box here, you want to isolate just that box. Don't show the ramp, don't show the pulley, don't show the other package. This one's a little more complex because everything's at angles. So the normal force is going this way. The surface is pressing up on the box going that way. So I normally would call that F of M. They're calling this rope that's pulling on the package, they're calling it T, tension. I would put F of T. It's really not that important. Just you want to be clear for the person that's looking at your diagram. This F of R, I'm assuming that is your friction trying to stop it. They once again used a different symbol. Really, you want to call off to the side. If you have a lot of these, call off what they represent. And then this would be the weight of the package. I always use FW. If I said draw a diagram of this package here, you would get rid of all of this, isolate so you only have this package. And with that one, you have a rope that's pulling up on it, and then mg, that's mass times gravity. That's the weight of that package. I would call that FW. I got a couple more examples here. Oh no, that's it. All right, I hope that helps out. Let me know if you have any questions at all.